Hello Year 10. I'm going to have a go at going through this paper for you. I know some of you had a few problems with some of the more difficult questions, but I just thought I'd talk you through the whole paper and I hope it helps. So this is the first time I've done anything like this, so please bear with me. Okay, lovely Year 10. So clearly the first question is nice and straightforward because you can see that picture C has got delocalized electrons, so that must be the metallic structure. Now, if you remember from your structures and bonding, if you have chains of polymers, they're held together by weak intermolecular forces, so E must be a polymer. Okay? Now, oh, blimey, my desk's not big enough. Never mind. In this question here, nice and straightforward, it tells you in the question, if you look, it tells you in the question that a chlorine atom has 7 electrons in the outer shell. Two chlorines bond covalently. Clearly, they want to have 8 electrons for that electrostatic stability, and they achieve that by sharing. Remember, you're going to do one shared pair because there's 7 electrons in the outer shell, and so they only need one shared pair to make that 8. Okay, now the big thing about simple covalent or small molecules is that you've got super strong covalent bonds between the atoms, okay, and then you've got weak intermolecular forces between the molecules, okay, and it's those weak forces between the molecules that make it make small molecules and chlorine have a low boiling point. Okay, now for this particular question, you need to notice that when it says what would the student see when the reaction takes place, what you need to do is take a close look at the states of matter of the products. Okay, if you see a gas, there will be fizzing. If you see a solid, there will be a solid being formed, and a solid is called a precipitate when it comes out of 2 reacting solutions. But the mark scheme, as you know, would accept solid. Okay, now for the next one, you guys needed to notice that the contents before mixing and the contents after mixing both added up to 257.68 grams, and that demonstrated the law of conservation of mass. No atoms are created or destroyed in a chemical reaction, they are just rearranged. Okay, so you can say something along those lines, but basically mass of reactants equals mass of products. Mass of reactants equals mass of products, and that's going to demonstrate your understanding. Okay, now the resolution of the balance to obtain the results, you can see here that there's 2 decimal places. So if there's 2 decimal places in the data in the table, then clearly you're going to have 2 decimal places as the resolution of the balance. Now, lovely ladies and lovely gentlemen, the formula for the potassium chromate is K2CrO4. It tells you the charge on the potassium ion is +1. Then it asks you for the formula of the chromate ion. Okay, now basically you can see that there are 2 potassiums. Okay, so there we've got 2 potassiums. So that means that you have got 2 positively charged ions in that formulae. Okay, so you are therefore going to need something with negatively charged ions to cancel out those positives. You know you've got 2 positives, so you need to find an ion with 2 negatives, and that would be this one here. Okay, ladies and gentlemen, or should I say lovely ladies and lovely gentlemen. Okay, now let me just move my camera ever so slightly, like so. That should be a little bit easier then. My desk won't get in the way. Okay, now another student also tests the law of conservation of mass using the same method. The student uses a different reaction with this equation, and again look at the state symbols of the products. And in this case you have got a gas being formed, okay? And if you have a gas being formed, then that will be given off, it won't be weighed as a product, and it will appear as if the results don't support the law of the conservation of mass. And the mark scheme just says carbon dioxide is a gas. Carbon dioxide is a gas. Okay, now this question is about group 7 elements. Chlorine is more reactive than iodine. Name the products when chlorine solution reacts with potassium iodide solution. Now that will take you back to your learning about the halogens that you did in year 9, that a more reactive halogen can displace a less reactive halogen from its compound. Okay, so the chlorine will come along, it will displace the iodide from potassium iodide, and you will form potassium chloride. And you will form iodine. Okay, now explaining why iodine is more reactive, why chlorine is more reactive than iodine. Okay, now remember, chlorine and iodine will have 7 electrons in their outer shell. Okay, iodine is bigger than chlorine, it has more shells. Okay, fluorine has got 2 shells, chlorine has got 3 shells, bromine has got 4 shells, and iodine has got 5 shells. Now, if you are a halogen, you're going to react by attracting or gaining an electron. It's going to be easier to gain that electron if you have less shells. There'll be a bigger electrostatic pull from the nucleus of chlorine, because there are fewer shells in the way and there's a bigger electrostatic attraction. For iodine, there will be a weaker pull. There's a greater distance of the outer shell from the pull of the nucleus, and that outer electron will be less easily gained. Okay, so in the mark scheme, you've got the 3 marks. Chlorine's outer electrons closer to the nucleus. Chlorine's outer electron closer to nucleus. Okay, oh, just squeeze that one in there. Chlorine nucleus, greater attraction for outer electrons. Chlorine nucleus, greater attraction for outer electrons. Okay, and final marking point that they've got is chlorine gains an electron more easily. Chlorine gains outer electron more easily. Or you could say that iodine gains an outer electron less easily. Now, you've all got the mark scheme. You can look at the mark scheme. Oh, I didn't realise you couldn't see all of that. Apologies for that. So you can look at the mark scheme, but that's just what that's all about. Now, in general, no disrespect intended by this, students do okay on bond energy calculations. Okay, but for this particular bond energy calculation, they've given you the overall energy change, and they want you to work out the bond energy for the missing CBr bond. Okay, so you need to work out your bonds broken and your bonds made, and remember, generally you do break minus make to find out the overall energy change, but you've got to do a little, sorry about that, you've got to do a little bit of wiggling in order to do this particular calculation. Okay, now remember, you are counting your bonds. 1, 2, 3, 4 CH bonds, 1 BR bond, then you've got 1, 2, 3 CH bonds, 1 CBr bond, 1 HBr bond. Okay, so just be very mindful of that. So, for your broken bonds, you have got 4 times 412, okay, plus 193, which gives you 1841, okay. Then you've got minus 51, which is your overall energy change, equals that bond broken value minus 1602, okay, for the made bonds, your 3 CHs and your HBr, plus X. And if you rearrange all of that, then you get the fact that X equals 290 kilojoules per mole. Okay, so that one is quite straightforward. If you've got any problems with any of it, please remember, we're going to have plenty of time back in school to sort things out before mocks in November, and you're not behind, you're in a really good place, so please don't worry. And you can always contact me if you need anything in the meantime. Okay, now here we've got a percentage atom economy question. Okay, and as usual with percentage atom economy questions, they pretty much give you it in a bag. You've just got to remember what it is that you've got to do. Okay, now the question says zinc sulfate can be made by 2 methods. So here is our zinc sulfate and our zinc sulfate. Clearly we are looking at different ways to make zinc sulfate. Now you can see that there is 1 product with method 1, but 2 products with method 2. Now, percentage atom economy is all about how many reactant atoms are rearranged into useful product atoms and how many reactant atoms are rearranged as waste product atoms. So it is your useful product atoms over the total amount of rearranged atoms multiplied by 100. Okay, so when it says to you, calculate the percentage atom economy for making zinc sulfate in method 1, okay, you're going to have to find out the relative formula mass of zinc sulfate, and then you're going to, which they give you, so pretty much give you this on the plate. So there you go, there's your 161 for your zinc sulfate. Then it says relative formula mass of zinc oxide plus the relative formula mass of sulfuric acid. Now you can take do it in a slightly easier way, because basically you know that due to the law of conservation of mass, the mass of your reactants is equal to the mass of your products, and you know that that is 161, and you know that that is 18 for water, so you can just add those two together rather than having to add those two together. But they've given it to you, so it doesn't really make an awful lot of difference. But in some questions, it will. Okay, so let me, so 161, 171, 179. So it's 161 divided by 179 multiplied by 100. You can see that you are asked to give your answer to 3 significant figures, and so you must give your answer to 3 significant figures. That is important. Hey, Mr. T, can I ring you back? I'm just doing a video for my year 10s. They can hear me talking to you, well, when I upload the video. So can I ring you back in a minute? All right then. Thank you. Bye. Sorry about that, folks. That was Mr. T ringing me about something related to physics, I've no doubt. Now, method 1 gives a higher percentage atom economy for making zinc sulfate than method 2. Okay, I'll just scroll down a bit there. Okay. Give a reason why it is important to use a reaction with high atom economy. It's all about less waste. Okay, so anything to do with less waste, and they do talk about sustainability. That's something that we touch upon in more detail later on this year. More waste, more sustainable. Sustainability increased. Let's have some good English, Mrs. Iles. Okay, so the MARC scheme does talk about allow any sensible economic or environmental reason, but not cheaper without qualification. So if you are going to say cheaper, you'll need to talk about why it's cheaper and give reasons for it. Okay. Now, the student uses 50 centimetres cubed of a zinc sulfate solution of 80 grams per dm cubed. What mass of zinc sulfate is dissolved in 50 centimetres cubed of this zinc sulfate solution? Okay, my lovely ladies and my lovely gentlemen, this is mass over concentration times volume. Okay, now you've got to remember that all of your volumes are in dm cubed. Okay, so if you jump that decimal point back, 50 cm cubed becomes 0.05 dm cubed. Okay, once you've turned your volume to dm cubed, it becomes very straightforward, and it's going to be your mass is concentration times volume. And your concentration is here, and it's a concentration because it's grams per dm cubed. Okay, so you're going to have your 80 times 0.05, and that is going to give you 4 grams. Okay, 4.00 grams. Although I don't know why they've put the 00 in brackets, but 4 grams is an acceptable answer on that one. Okay, so hopefully that one's straightforward for you. Now, I know that some of you found this question a little bit tricky because you've told me that you have. Okay, and let me just say, for titration questions, you just need to approach them systematically. Now, you can see that we are talking moles per dm cubed. Okay, so this question is about acids and alkalis. A student titrated 25 centimetres cubed portions of dilute sulfuric acid with a 0.105 moles per dm cubed sodium hydroxide solution. Okay, and you are going to calculate the concentration of the sulfuric acid in moles per dm cubed. So we are going to use, just move that over slightly, we're going to use number of moles concentration times volume. Okay, that's the equation of triangle that we are going to use. Now, I'll put it up here as well so that we've got it up here. There we go. Number of moles, concentration times volume. Okay, so we have got 0.105 moles per dm cubed sodium hydroxide solution and 25 centimetre cubed portions of acid. Now, as I've said to you before, in a question like this, one of the first things you're going to do is turn that, let's get that right, turn that volume to dm cubed straight away. Okay, then we've got our volumes of sodium hydroxide here. Now, it says here, use only the student's concordant results, and it tells you that concordant results are those within 0.1 cm cubed of each other. Okay, so we discard that one, we discard that one, and we just use these three volumes here to find out our average titer for our sodium hydroxide. Okay, so I'm going to write this up here. Average titer is going to be 22.13 cm cubed. Okay, but straight away, without further ado, I'm going to cross that out and write 0.02213 dm cubed. Okay, let me just show you what I've written. So I've written that there. Okay, now I just find the best way with these titration calculations, if you find them tricky, is to be as systematic as possible. Now, in this particular question, you know the concentration of the sodium hydroxide. You don't know the concentration of the acid. So your known is the sodium hydroxide, and your unknown is the sulfuric acid. Okay, and in case you need the formulae for those, you've got them in the balanced symbol equation. Okay, so in order to be able to work out an unknown concentration, you need to be able to directly compare the moles of acid and the moles of alkali that reacted in this titration. Okay, so number of moles equals concentration times volume. Using number of moles equals concentration times volume, we can work out how many moles of sodium hydroxide we used. So our concentration is 0.105 for our sodium hydroxide, and our volume is 0.02213. Now, a classic error at this point is to multiply the wrong numbers together. Okay, and when you've multiplied those together, you should get your number of moles as 0.00, let me put my point in, 0.002324. Okay, and that is your number of moles. That is how much sodium hydroxide you used in moles. Okay, now, ladies and gentlemen, I need to draw your attention to the mole ratio. 2 moles of sodium hydroxide react with 1 mole of sulfuric acid. So to work out the concentration of our sulfuric acid, concentration equals number of moles divided by volume. Okay, we know what our volume is. Our volume is 0.025, and we can work out our number of moles from the mole ratio. So our number of moles is going to be 0.002324 divided by 2, okay, which is going to give us 0.001162. 0.001162. 0.001162 moles of sulfuric acid. Okay, and if you do 0.001162 divided by 0.025, you should get an answer of 0.0465, okay, and you genuinely 0.0465, you generally give your answer to the same number of significant figures, well, you don't generally, you do, as the lowest number of significant figures in the question. And we've got 3 significant figures in the question, so we leave our answer at 3 significant figures. Okay, folks, now, a number of you have come back to me saying, titration, please don't worry. We have plenty of time. We will come back to it. You will be fine. Okay? And you can always work your way through the exam paper and the mark scheme using this to help you. Just get your head around it and make sure you understand it. That's all I need you to do at this time. Okay? Now, moving slightly up. Explain why the student should use a pipette to measure the acid and a burette to measure the sodium hydroxide. Well, a pipette is used for a fixed volume and a burette when you don't know what the volume's going to be. Okay, pipette, fixed volume, burette, pipette, fixed volume, and burette, variable volume. You don't know what the volume is going to be. Okay, now for this next question, calculate the mass of sodium hydroxide in 30 centimeters cubed of a 0.105 moles per dm cubed solution. Okay, so this is what we're going to do, folks. We're going to work it out in moles, and then we're going to convert the moles to mass. So we're going to use 2 equation triangles. Okay, so if I move that up slightly, calculate the mass of sodium hydroxide in 30 centimeters cubed. So we've got to use number of moles over concentration times volume for the first part of this. Okay, so I'll just put a 1 there. So we've got to remember that we've got to turn all our volumes to dm cubed. Okay, we've got to work out exactly how many moles there are in 30 cm cubed of a solution of 0.15 moles per dm cubed. Okay, because that's a concentration. So our number of moles is going to be concentration times volume. Okay, so we're going to have 0.105 times 0.030. Okay, I'm not sure that they're doing it quite, oh no, they are doing it my way, so that's good. So that comes out at 0.00315 moles. Okay, then we use good old mass over Mr. Mole. Okay, and when we use mass over Mr. Mole, what we're doing is we are working out what our mass is. We're taking our number of moles and we're multiplying it by the MR of sodium hydroxide, okay, which is going to be 40, and that should come out as 0.126 grams. Now they've done it slightly differently, and I just want to, I know it's fine, but I do like to just double check. So we've got 0.00315 multiplied by 40 equals, there we go, and you can see there it is. Okay, folks. Now, hopefully that made sense. And again, plenty of time. Just want you to get your head around it. All you need to do right now is understand it. Practice, practice will come later. Okay? Now, last but not least, a question on electrolysis. So this question is about magnesium and magnesium chloride. Magnesium chloride can be electrolyzed. The diagram below shows 2 experiments for electrolyzing magnesium chloride. Explain why magnesium chloride must be molten or dissolved in water to be electrolyzed. Now, key error here is for students to talk about electrons. It's not electrons, it's ions. Ions must be free to move. Okay? Explain how magnesium is produced at the negative electrode in experiment 1. Okay, well, in experiment 1, okay, it's molten. So you have got Mg2 plus ions at your negative electrode and Cl minus ions at your positive electrode, and that's all there is. Okay, there's no solution, there's no H plus ions, there's no OH minus ions, there's nothing to complicate the chemistry. So all that happens is that your magnesium ions gain electrons to become magnesium. Okay, so Mg2 plus ions attracted and reduced, gain electrons to magnesium atoms. Oh, sorry about that. Okay, so magnesium ions attracted and reduced to magnesium atoms. So that happens because it's not a solution. Okay, however, in experiment 2, at the negative electrode, you've got hydrogen ions and you've got magnesium ions. You have chloride ions and you have hydroxide ions. All of a sudden, the rules change. Okay, now you remember for my cathode rules, okay, at the cathode, the first thing that will happen if they're there is copper, silver or gold will be deposited. If they're not there, hydrogen will gain electrons, and become hydrogen gas. Okay, and that's all that can happen. As soon as you're in solution, that's all that can happen. Okay, so basically, the magnesium ion stays in solution. And obviously at the anode, the first thing that happens is chloride, bromide and iodide are discharged. And if they're not there, hydroxide will be discharged as oxygen, water and 4 electrons. Okay, so when it says a gas is produced at the negative electrode, name the gas, that's got to be hydrogen, folks. Complete and balance the half equation for the reaction at the positive electrode. Now remember what I told you, folks. If you've got a negative ion, draw an arrow by it and split it up into whatever it is and its electron. If you have a positive ion, add electrons to it to turn it into whatever it is. Okay, so you know this has got to be E minus. you've got a 2 there, so you put a 2 there, 2 there, and Bob's your uncle, or your husband in my case. Okay, folks? Now, I've taken the trouble to do that because I've had a number of you sending me worries about certain questions. So please, 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 your next lesson is to go through with a fine-tooth comb, and I'll post some videos that can help with your understanding of things. And don't worry, we've got plenty of time to support and help you with this. All right, folks? Speak to you soon.